Welcome to video 10 on the Intro to Python series for Statistics class for engineers, STA 3032. This video we're going to be covering summary statistics from data frames. So data frames are something that exists inside of pandas, and only pandas is all we're going to need for this video. So we're going to import pandas as PD. So as a reminder, what that does is it's going to give us all the libraries that have been defined inside of pandas. And one of the best libraries that's inside of pandas is the read CSV method, and that gives us the ability to read in data. So let's look at how that data looks like in a file. So C program files. Here's where I installed my my Jupyter or my WinPython, and then all my notebooks. This is our Intro to Python series, and so the relative path would be data and then store_data.csv. So you'll notice my computer has CSV files associated with Excel, so if I double click on it, it'll open the file in Excel. And you can see it's just looks just like a regular Excel file. We have a date column, a customer column, an item column, quantity, and unit price. And that's going to be our file, and if we go ahead and import it into pandas and print it out, you'll see our data frame, which is really what this is. It's a data frame. We're just calling it data. But if you look at the API documentation for the read CSV, it returns back a data frame. I do type. You see that it's in the class of data frame. So let's print back the data so we can see it. It doesn't have an ID column, so these are our index numbers. You'll see that there's 15 rows of data, and then the headers are date, customer, item, quantity, and unit price. And quantity and unit price are numeric values, and you'll see that it's got an NaN for quantity and a NaN for unit price for customers 13 and 14 respectively. And if you go to Excel, what does that look like in Excel? Well, Excel treats that as just missing data. So in Python, you'll see it say NaN. In other places, you may see it just as blank cell missing. But either way, the data doesn't exist. And that often happens when you're collecting statistics for some reason. The data gets messed up, or when you're sampling, something got corrupted, so you didn't get a sample for one of your measurements. But not a big deal. There's ways to work with missing data. Sometimes with this data case, we only have 15 rows, so printing it out doesn't take too much scrolling to see the whole thing. But there's two methods that we're going to talk about, head and tail. And head gives us, if you type in data.head, it only gives us the first 5 rows of data, so 0 through 4 here. And that way you can make sure that your data was loaded correctly, but it doesn't display the whole data set, so you don't have to scroll for pages and pages if the data set's huge. And then the other thing we can do now that we have the data, we have date, customer, item, quantity, unit price. Well, let's create a column called total, which gives us quantity times unit price. All we got to do is declare a column called total and set it equal to the multiplication of quantity times unit price. And if we do that, we'll do the head, and you'll see that it does in fact create a new column called total, and it's just so here this row, for instance, is 5 times 2 gives us 10. So it creates a new column based on the multiplication of quantity times unit price. And I did head, so it only showed me the first 5 rows. If I do tail, it goes to the bottom 5 rows. So that's a quick way to look at your data without having to print the whole thing out. If you recall back one of the earlier videos, here I'm declaring a string called test, I'm declaring another string called test2, and if we try to do the math summation of the two strings and assign it to this new thing called summing of the two strings, you see what it does is it just concatenates the two strings right one after the other. So no spaces between the two, it just says test, test2. And that's what happens when you sum strings together. What happens when you sum an entire data frame together? So there's a method called sum that you can run on data frames. And the concept of summing strings together is exactly what it does for anything that's a non-numeric column. So for our date, our customer, and our items, it literally sums the strings together as one gigantic long string. So milk, orange, apple, banana. And if you go to our data and you look at the head, you see milk, orange, banana, orange, apple. And that's exactly what you see here: milk, orange, banana, orange, apple. But for the for the numeric columns, it actually gives us meaningful data where it's summing something that's meaningful. So the quantities, how many items have we sold total, is 28. What's the sum of all the unit prices together is 1,033. And how much money did we make, which is the total items times unit price, and we've made on our sales $2,064. Now, it doesn't make sense to sum date, customer, and item. Is there a way to sum just the ones we care about? So in case we only care about quantity and total, you can just tell it to only give me those columns and then run your same sum method on that, and it'll only give you quantity and total. So that's a way to filter out the meaningless data, only what you care about. And you can do the same thing with sum. There's other methods. You can do mean. It'll give you the mean of those, or median. And I'll do the mean here. And you can see that the quantity mean is the same as the median, but the mean for total is way different, because there's an outlier in the data. So if we go back all the way up to our big data set, you'll see that most things are 1, 2, 3s, 5, but then you have this gold nuggets that was huge. It was $1,000 for that item, and that's what's throwing off our mean. So the mean's very sensitive to large outliers, whereas the median is insensitive to outliers. So you can see that here in using the mean and the median. Now, moving on here, we talked about missing data, and there's two ways to do missing data, or there's actually multiple ways, but the three that I'm going to talk about is we can either drop it, so anything that has missing data we're just going to ignore and not use in our data set. If we want to use it for some reason or another, a valid thing we might want to do is say, let's take the mean and apply the mean to that. So wherever there's a missing value, let's just assume it's the mean, and that way we can still have the data in our data set. And the other thing we can do is just set the value to 0. So let's see what those look like. So here I'm going to create two new variables: data where the NaNs have been applied as the mean, and then data where we just drop any of the NAs. So now let's look at the tail end of where we use the mean value, and you can see here under unit price we had that NaN right here, and we've now put in 73.75 because that was the mean. We could also put in the median, which may be a better idea in this case, because then we get a value of 3 here, and that's probably a closer representation. So the outlier is what's driving this to be so large. But for the purposes of this example, we're going to assume median. And then let's look at what the drop, where we dropped all the NAs, and what that looks like. So you'll see that we don't have the last two, so it goes from 8, 9, 10, 11, and 12. We're missing 13 and 14, and that's because they had a NaN, and so it dropped those. So if we print unit price and we print the mean, you'll see that that was the 73.78 that we had before, and that is off the raw data. So we didn't tell it to do anything with NaNs. What is it going to do? It's going to calculate the mean and just use the mean as the value for that. Let's print the same data, except for now we're going to use the data set where we set the unit price to be the mean, and you'll see that these two methods are identical. So What that means is Python by default in data frames, if you say I want the mean of a column, it's going to assume that the NA's values are the mean value, and that's how it's going to do its calculation. You'll see now that if I print the unit price with the where we drop the NaN, so there's no NaNs in this file, they're just removed, you'll see that it raises the average for the unit price, because those two columns, or in that case it's the one column that's missing because we didn't we dropped the NaN that was actually the two columns, so we dropped the NaNs that were in quantity and unit price. So that offset is now much more sensitive to the mean of the large outlier, the 1000 for the gold nuggets. See, has a major impact when you remove the NaN values. If we filled the NaNs with the value 0, it drops the mean value because it's basically an outlier on the underside rather than an outlier on the overside of the 1000. So valid things to do is just take the mean, drop NaNs, or fill them with zeros. I've seen all done in various forms inside journal articles that are dealing with data, but it depends on why you need the data, what you want to do with the missing data, and as long as you document and have reasons for why you're doing it, those three methods are all valid. Now, this whole time we've been working on data frames, there's a bunch of different methods you could run. We ran sum and we ran mean and median, but you can also do min, you can do, Control Enter, you can do max, you can count. There's a bunch of different methods that you can run on your data. So for instance, the unit price, we can run the median. You'll see that it's 3, mean 73. If I do max, you'll see that it's the 1000, min is 1. So you can run all these different methods on your data. You can also sort your data. So when you're trying to print out something for a table for a chart or something, you can also sort by different values, and you can fill your NAs with 0 for this case. You'll see that 0 is here. That's the value that was an NA. This column here is our index column. So before, that was the last set of data. That was this one here. And because we set NAs to be 0, it put in a value of 0 here. So that's what happened here. And then we sorted them smallest to largest. So that's why I go 0 all the way up to 1000. And like I showed, you can do the max. And then there's one other thing we can do is called the ID max, IDX, the index of where the max value is found. And you'll see that that was found at the 8th row in the data. So it's actually the 9th row because it's 0 based. So if you go all the way back up to the top here and you look at 8 here, you'll see that's where we have our max value of 1000. So IDX max gives us the index. And why do we care about the index? Well, sometimes we want to figure out something based on the index, like what item was that? So we do our data, we put it in square brackets, then we put in quotes our column name, in this case it's item, and then we're going to tell it we want to know the 8th row of that and what was that item. And apparently that was gold nuggets, and obviously gold nuggets cost more than everything else, apples and bananas. Now we're moving on to one more method, and this is one that I really like, is the describe method. And this, for any data that is numeric, so any column that has numeric data, describe is going to give you a bunch of descriptive statistics on it. So if I hit Control Enter here, you'll see that quantity, unit price, and total are all numeric valued. So it's the only ones that it'll work on. So the ones that are string based or date time, those don't get summary statistics. But the describe gives you, in one little method call, gives you the count, mean, standard deviation, your min and max, and then your percentiles, starting with your median, and then your lower quartile and upper quartile. So that's a nice little cool method called describe. And then I'm going to print out the data just so we have it again in our ready at our fingertips to be able to see, because there's 3 or 4 more items I want to come over. Unique. Another method that we can run on our data is to look for the unique items. And this is, so we have orange, apple, banana, milk, banana. Well, we have multiple bananas, we have multiple milks. So unique is going to give us back a set of values that don't have duplicates. So you'll see that these are all the unique items that we have with gold nuggets, apples, bananas, oranges, and milk. And we can also look at counts, right? So how many of each unique item do we have? So bananas, we have 6 of them. We've sold 6 line items that have the word banana in it as item. You can see that gold nuggets, we only have 1, and this just gives you a nice quick way of seeing how many items exist, how many rows exist with those particular items. Let's print out our quantity. So you can see that our data has NaN in it still. It has 2s, 1s, 3s, and 5s, right? Well, one of the nice things to do with discrete data or even continuous data in some instances is you want a quick histogram. Well, Pandas uses matplotlib, but it has a quick little hist function that you can run. So you tell it what data column you want. So in this case we want quantity, and we want to perform a quick histogram on it. So you'll see that it runs that, and then it should do a pop-up. Oh, I guess it didn't do a pop-up. What happened here? There it goes. Took a minute to run. But there it goes. It calculated the histogram. So there's 6 instances. There's 4 instances of 2, so forth, that kind of thing, right? Nice, easy plot of histogram based on our column of data that we care about. All right, we've got one more video to go. I'll try to get to it soon, but you're almost done to having the basics of what you need to know for the assignment.